Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 7, Lesson 2, Evaluating Log Expressions. Now, if I want to be a poo head here, this is about as poo head as I can get with this section. Which expression is the greater value? Now, as I said, later I'll show you how to do this on a calculator. So right now, I need you to be able to convert these logs to exponents. So, we'll call this x. Log base 2 of 16 equals, I should write that to one side, it's a mess, equals x. So this is a log where it is an exponent. It's 2 to the x equals 16. Now, common base, 2 to what power gives us 16? 2 is a 4 to 4 bit. 2 to the 4. So x equals 4. So this is 4 plus, now log base 2 of 2, I'm going to call that another x because I can. So this is 2 to the x equals 2. Now when I write it like that, that's my exponent to the 1. To the 1. So this is x equals 1, 4 plus 1. So this whole side is 5. Now I realize I did that rather quickly. But that's pretty straightforward. I'm going to try to slow down for the next one. Okay. So log base 2 of 1, that's x. So this is, as an exponent, base 2, power of x equals 1. What the heck? Think about it for a second. We did these with exponents, and it's a little sneaky, which is why I'm helping you with this. That's 2 to the 0. Don't believe me? Grab your calculator. Actually, a better way to show this. Clear. Better way to show this is 2 to the power of x. That's an easy way. Table of values. 2 to the 0 is 1. 2 to the minus 1 is a half. 2 to the minus 2 is 1/4. There we go. Anyway, 2 to the 0 is 1. Now, so this is x equals 0, so this whole thing is 0. Now the other term is sneaky. 2 to the x equals 1/8. Now, when I say if that's 2 to the x is 8, most of you should be going, oh, that's 2 cubed. Remember the exponent stuff we talked about? Now that means, we're close, but we have to flip it. So 2 to the x equals 2 to the minus 3. Or x equals minus 3. Or 0 minus 3. This is 3. See how that goes? And note 5 is bigger than 3. So this is something I expect you to be able to do because I'm a poo head. Okay? Now, moving on. Word questions. The pH scale in chemistry is used to measure the acidity of a solution. The pH scale is logarithmic with a base of 10. A logarithmic scale is used for comparing numbers that vary greatly in size. So, the pH, or P of x, is defined by the equation P of x equals minus the log of x, where the concentration of hydrogen ions x in the solution is measured in moles per liter. Those of you that have taken chemistry should know this, and laugh at you that those didn't, but whatever. So, let's do a couple questions. The hydrogen ion concentration x of solution is 0.001 moles per liter. Calculate the pH. As we just said, the pH, or P of x, if we want to get all fancy and write it as a function notation, minus the log of x. So this is minus the log of 0.0001. So, okay, Mr. Calculator. negative log 0.000, too many zeros, sorry. Must be a point in there, I missed the decimal, so point 0, come on, 1. Is it 3 zeros? Yes, it is. Now notice I used this negative sign, not minus. Okay, be careful with that. And enter. Oh. pH of the solution is 4. Moderately acidic, fairly good way to get rid of the body. Did I say that out loud? No. Okay. Now, lemon juice is a pH of 2. What is the hydrogen ion concentration of the lemon juice? Oh. pH minus the log of hydrogen ion concentration X. Now, this is a trick. I want you to pay very careful attention here because I promise you you're going to see it again because I'm not sort of a poo head. The pH is 2. Now the thing is, we have to turn this into an exponent. Actually, there's 2 tricks. One, this is base 10. Since I didn't say otherwise, well, I did say this is base 10. Never mind. The trick here is the minus sign. You start taking these, turning the base, sorry, turning the log into an exponent. It's got to be log of 10, not minus log of base 10. So I multiply both sides by minus 1. So it's minus 2 equals log base 10 of x. Now for this, once you get the minus with the 2, and it's just log of something, you're all set because turn it into an exponent. X equals 10 to the minus 2. And the power of negative 2 is 0.01. And just molar, for those of you chemistry people that are slowly freaking out because I forgot to write it out. Okay. Okay so far? Well, I hope so. Now, last question. Oh, last question. In terms of hydrogen ion concentration, how much more acidic is solution A with a pH of 1.6 than solution B with a pH of 2.5? Okay. Round your answer to the nearest tenth. Right, so solution A is 1.6. And solution B is 2.5, so that's 2.5. Okay, I'm going to pause. I'm going to start the red one to figure out X for the first solution. Then I'm going to pause the recording, and I want you to figure out the pH of the second. Sorry, the concentration of the second solution. So as I was saying before, got to get rid of the minus sign. So minus 1, multiply both sides by minus 1. So this is minus 1.6 equals log of x. Now I'm going to pause the recording here. I'm going to figure out what x is because this is 10 to the minus 1.6. And I want you guys to do the same thing for the green equation as a solution to B and tell me what the answers are. So come back when you're done. Let's go. Okay. Solution A is 0.0251 molar. B, 0.0032 molar. Much less concentrated, or more dilute. So, the question is, in terms of hydrogen ion concentration, how much more acidic? Well, those are being poo heads. So more acidic divided by less acidic. How many times is 0.0032 going to 0.025? I have about 7.9 times. Yeah, solution A is about 8 times more safe. So that's using logs and equivalency, logs to exponents. All right? That I need you to be able to do. If you've got it, work on the classwork. If not, shoot me an email or send me in class tomorrow. Good luck.